Okay, so we have our problems from 8.3 and 8.4, and we're going to go through a couple of these together as a group from 8.3 and a couple again as a group of 8.4, and then I'm going to have you work in teams on the rest of them. Again, you know, it's practicing and doing them from the beginning to the end. So let's look at number 10 there on M&Ms. This is 8.3, 8.4. Oh, thank you. Yeah, these are going to be the problems from 8.3 and 8.4. You only have 8.2? Okay, let's see if I have some more up here. Okay, see if that's enough to go around. Does everybody else have the 8.3, 8.4? Okay, there's one. Um, here's another one. Just two of you need it? We got one more? Ugh, I don't know if I have them. I do. Okay, and you have the formula sheet, right? Okay, so that's very first problem. Um, M&Ms, the data set number 20 in the appendix lists data for 100 M&Ms, and 8% of them are brown. Use a 0.05 significance level to test the claim of the Mars Candy Company that the percentage of brown M&Ms is equal to 13%. Okay? The first thing you need to do is decide, am I testing the hypothesis about a proportion or about a mean? It is a proportion because it says percent. That's what gives it away. So it is a proportion. So that it's a proportion, we then know we have to use what's the Z or the T? Z. Okay, good. Then we want to decide here what our claim is symbolically. Just the claim. So the Mars Candy Company, that the percentage of brown M&Ms is equal to 13%. So my claim is that the proportion will be equal to 13%. And I could write 0.13, I could write 13 out of 100. They all mean the same thing, right? Now that I have my claim, I'm ready to write my null hypothesis. What was my null hypothesis going to be in this case? P is equal to 0.13. Remember, my null hypothesis has to be equal. It can't be less than, can't be greater than with it. It can only be equal. From that claim written symbolically, I also know how to write my alternative hypothesis. Because this one only has equals as my claim, I'm going to write my alternate as not equal. Okay? Everybody all right? Okay, let's go. I'm going to have to just move down here and grab some more space. Or just go and add a page. Okay. From that, I have to determine now, is this a one-tailed or a two-tailed test? It is a two-tailed test. Why? Because it's not equal, right? There's nothing there that says less than, there's nothing there that says greater than, so it's going to be a two-tailed test. Okay? So I have to calculate out my z-score, and you have your formula sheet there, right? So z is going to be p hat minus p, all divided by the square root of p times q divided by n. What's p hat? 0.08. Remember that p hat is always the proportion of the sample that I took, not the population. P is the proportion for the population. Okay? And Q is the opposite, right? 1 minus P. So in this case, my sample was 8%, right? Minus my population. I'm going to divide by the square root of P. P is 0.13. Then I'm going to multiply by Q. Q is 1 minus 0.13, so it's going to be 0.87. All that has to be divided by n. Well, what was n? 100. It told me my sample, I had 100 M&Ms. Okay? Got several of you calculating it out. Tell me what that's going to be. Negative 1.487. Okay? So what am I testing at? A level of significance was 0.05, correct? So let's look at our in this tail, I'm going to have 0.025 and 0.025 because I have to split that 0.5 into the two tails. Okay? So here's the z that I came up with. How am I going to find the z for my critical values? Inverse norm, I'm going to go to my calculator and I'm going to pull that up and say inverse norm. You guys can get there a lot faster than I can, right? So second distribution, Don said it's going to be negative 1.16. I'm going to put 0.25 as my area. I come down, I've got my mu is 0, alpha sigma is 1, and it is negative 1.96. What's this one then going to be? Positive 1.96. Good. My z that I calculated is negative 1.487. Negative 1.487. Where is negative 1.487 going to fall on this curve? Could have put a 0 in there, huh? Yeah, it's going to fall somewhere down here, isn't it? So, am I going to reject or fail to reject the null hypothesis? Fail to reject. And so you now have to state the conclusion without using this reject or fail to reject. And there was a chart I gave you in wording the final conclusion. Everybody has that chart. That was from your notes from 8.2. And it's really hard to read if yours hopefully is better. Say that again. Else, you know, I was just looking for it in the textbook, and I couldn't find it in the textbook. So,
Or do we have access to this slideshow?
mhm.
If we have access to this slideshow, when you go to print it, you can just figure out what slide it is and then just
Print that one slide.
itself as a full
Right.
page. It'll probably come out a lot better.
Yeah, let me see if I can at least pull it up so we can read it better. I know, it's very difficult to read it. So I was looking for the calc in the textbook and it wasn't there. It's like, oh,
Since that there is no sufficient
there's not
evidence
sufficient
for
evidence.
rejection of the claim that M&M's at 13% of M&M's brown.
Okay, that's a little bit better. So this is how we do our claim. First, we go back. Does the original claim contain the condition of equality? Did this one? Yes, it was. The proportion is equal to 13%. It was very clear it did contain equality. So I'm going to go yes, that it contained equality. Do you reject? Did we reject? No, so we failed to reject. So how we're going to put it here, there is not sufficient evidence to warrant rejection of the claim that there are 13% brown M&Ms. Okay? I'll have to think about it. There is not sufficient evidence to warrant the rejection of the claim, to support rejecting the claim. Okay, you can say that, and then you have to state what the claim is. That's a good idea. Don's taking a picture. If you guys want to use your phone and take a picture, you can do that. I'm fine with that. I'll even get out of the way so that you can do that. Everybody's got their phones taking pictures, right? Because I know how it was very difficult to read on the materials that were distributed. Okay. Too small from back there? Okay. Back to, since we failed to reject, we're going to state there is not sufficient evidence to warrant rejection of the claim that 13% of M&Ms are brown. Okay, so we've gone from the very beginning and worked our way through the entire thing. Okay. All right, let's go now to number 11, about identity theft. In a KRC research poll, 1,002 adults were asked if they felt vulnerable to identity theft, and 531 of them said yes. Use a 0.05 significance level to test the claim that the majority of adults feel vulnerable to identity theft. Excuse me. Is this going to be a proportion or is this going to be a mean? Proportion. Because I have 531 out of 102. Okay? So that's going to be a proportion. It's going to be a percent. So right then I know I'm going to use what? Z or T? Z. Okay? I'm using a 0.05 significance level. And here's the claim. The majority of adults feel vulnerable to identity theft. That's a different than any of the claims we've seen yet. What does majority mean? Most. Would majority be anything over 50%? Yeah. So our claim is that the proportion is what? Greater than 0.05. That's my claim. From my claim, we already know what our null hypothesis has to be. It can only have equals, right? That's the only thing a null hypothesis can have. So the null hypothesis is going to be that P is equal to 0.50. And this is the one that, because the claim does not have equals in it, I'm going to use this as my alternative hypothesis. Remember we created that slide together? To help determine what that alternative hypothesis is. It did not have equality in the claim, so that claim becomes my alternative. Okay? So this is identity theft. And what was it, 531 out of? We have our null hypothesis of P is equal to 0.50. We have our alternative that P is greater than 0.50. Okay? We already said we're going to use the Z calculation. Somebody quickly do 531 divided by 1002 and let me know what that is. 0.529. So I think we can, pardon me? 5299. So how about if we round that to 0.53? Okay. Remember what our Z formula is? It's P hat minus P. This is what? This is P hat. That's my sample proportion. Remember, we're going to label everything because we have P's all over the place, right? Okay. So I'm going to have P hat 0.53 minus P 0.50 divided by the square root of P times Q. That's the proportion for the population. And of course, Q is going to be 1 minus it, all divided by N, which was the number in my sample. N is 1002. $1.895. If I'm going to round my Z to 2 decimal points, that's going to round to 1 point what? 1.90, right? 1.90. Okay. Is this a one-way or a two-way test, two-tail test? It's a one-tailed test because it is greater than, correct? This says greater than. This is telling me it's a one-tailed test. And greater than is what? To the right, correct? So the area here has to be what? 0.05. So now I have to find out what my z-score is for that, correct? Again, to find my z, I'm going to use my calculator to get the area. Again, there's 2 ways I can do this. I can just enter 0.05 and I know I'm going to get the negative and it's going to be the same, or I can just enter 0.95. .64. So my critical value is 1.64. So, what do you think? Reject, can I? Why? Where is 1.9? 1.9 is up here, right? So that means I can reject the null hypothesis. So we're going to go back to that slide. We didn't do p-values, but I want to do this and then we'll come back to p-values. Did the claim have equality in the very beginning? No. It said the majority. That's not equal, it's greater than, right? So since that, I'm going to go this route. Did we reject? Yes, we rejected. So The way to state it is the sample data support the claim that so let's go back to that file. The majority of, yes, that was the claim. The sample data support the claim that the majority, if I could spell, of adults feel vulnerable to identity theft. Okay?
When you're finished with the station, I just have a question about that. Where it's 5
Oh, okay, okay. How did I come up with that Z? Is that what?
and I think we dropped out.
Okay, so your confusion is how we found this number.
No, the area of the
Why this is 0.05?
yeah.
Because it says my significance level is 0.05.
But not past.
It was a significance level of 0.05, but it was two-tailed test. So I have to take that 0.05 and split it into two tails.
Will be on the sheet. Or you guys on the sheet.
That won't be on the sheet. You just, if it's two-tailed, it has to be half in one tail and half in the other. And I'm going to have a two-tail only when I have my alternative hypothesis says does not equal 2.
Okay, so you're very particular to 5. Okay, I get it.
Okay?
I thought you were getting that from somewhere.
Okay. All right, good. Everybody sees that. The way we didn't do it, though, is p-values. And we can very quickly do it for p-values because I want you to know both ways. We still have to calculate and find the z, and this is my z, right? Okay. So by going to your z, you're going to go to second distribution, just like we've done before, normal curve distribution. My lower level is going to be that 9999, negative 99999. And I'm going to go up to the z that we found of 1.9. And I find that that area is 0.9713. That would be the area from here all the way to the 1.9. So if I say 1 minus that, what am I going to end up with? .0387. This is my p-value. My p-value is 0.0387. 0.287. Okay? That's my p-value. My significance level is 0.05, right? Is this less or more? That's less, isn't it? So I still get the same result. I need to reject the null hypothesis because it's still telling me it's way down here in this rejection area. Okay? Everybody all right? Okay. So 12 is very similar to that. I'm going to skip that one. I'm going to let you work on those. Let's go to one from 8.4. Here we go. Starts with number 11. So it's Oscar winning actresses from a data set. It lists the ages of the actresses when they won their Oscars. They've then given us the summary statistics of an N of 82, X bar is 35.9, and the sample standard deviation is 11.1 years. Use a significance level of 0.01 to test the claim that the mean age of an actress when they win Oscars is 33 years. Okay? Are we testing a proportion or are we testing a mean? Mean. Okay? Am I going to use the T or the Z and Y? I'm going to use the T distribution because I do not know the standard deviation of the population. Yes, I know the standard deviation of the sample, but not the standard deviation of the population. So I know I have to use the T test. My claim how am I going to write my claim symbolically? Mu equals 33. My null hypothesis still has to be mu equals 33, right? How about my alternative hypothesis? It's not equal to, good. Because it doesn't say they're going to be older or younger. It just says they're 33. Okay? And we're using the T statistic. Okay? So this is the age of Oscar winners. Mu is 33. The alternative is U does not equal 33. Our significance level this time is 0.01. 0.01. And we know we're going to use a t-test, correct? So from your formula here, we know that t is equal to x bar minus mu, all divided by the sample standard deviation divided by the square root of n. What was x bar? You guys have the sheet in front of you. I don't. It was what? 35.9. Mu is, and how many actresses were there? 82. And what was the standard deviation of the sample? Somebody run that through and tell me what your what's my t come out to be? 2.37? 2.39. You got 3.7? More 3.7? 2.37. Okay. I did not bring our t-charts with us, but from our t-chart I can tell you what the critical value of that's going to be. The t critical values would be plus or minus 2.639. So what am I going to do? Am I going to reject or fail to reject? Draw your, if you're unsure, draw your quick sketch. There's 0. My critical values are positive and negative 2.639. Where is my t going to fall? 2.37. Right in here, isn't it? So I'm going to fail to reject. Fail to reject. So I'm failing to reject. Did the original claim have equality? Yes. So yes. Did we reject? No. So how we're going to state it is there is not sufficient evidence to warrant rejection of the claim. There is not sufficient evidence to warrant rejection of the claim. To warrant rejection of the claim. The mean age is 33. Okay? Is it making sense? So it's not too bad now that we've put everything together. You just really got to watch. Yes, for the T. Yep. One-tailed or two-tailed. This happened to be a two-tailed because it was not equal to. Yep. Exactly. Exactly.
The hard part for me is putting this in the calculator.
Okay, what are we trying to put in the calculator?
I said 35.9 and 33 in the parentheses divided by another parentheses 11.1 divided by the square root 82 and parentheses. I got 2.36. Oh, is that it?
That's
Oh,
it.
okay.
2.36 something that makes it round up.